And this was a solution. Okay, so in x2 plus x3 equaling 1. So now I just look at the x2 and x3 columns, and the one column, the x1 column, becomes don't care. Actually, let me just erase the don't care, because now that's not totally applicable.
Or just move it over to the x1.
Yeah, but it was applicable in the first decision, but it won't be applicable in the second decision.
Oh, okay.
And this table kind of shows both of them. So for the, I mean, it'll be recorded in this video, the fact that for x2, for the red boxes, x2 is the don't care, and then I'm going to make this blue box for x1, actually. But first I need to write the answers. So now we're looking at x2 and x3. So 0 plus 0 is 0. 0 plus 1, whoops, is 1. 1 plus 0 is 1. 1 plus 1 is 0. 0 plus 0 is 0. 1 plus 1 is 1. 1 plus 0 is 0. And 1 plus 1 is 0. Oops. This 1 plus 0 is not 0. Also, I probably didn't have to do it for every single one, because really I'm just looking for the red ones where this other equation is true, right? Whoops. Because we care about the intersection of these two sets. So I probably didn't have to generate the whole set for my second equation, but I did anyway. So this one, so we're looking for when x2 plus x3 is 1. So this would be a solution. And this would be a solution. This would be a solution. And this would be a solution. Nope, that wouldn't be a solution. It's this one would be a solution. So the intersection are the, whoops, not that whole thing, are the answers that have both a red and a blue box around them.
Mm-hmm.
So our answer would be, so we'd have flat of S equals the set. So this one had both, had a blue and a red box around it. So that's 0, whoops. 0, 0, 1. Whoops. And this one had two boxes around it. So that's 1, 1, 1. So that would be my solution set if this was my set of equations.
Wait, I got a question. Can you do the flat sets again? I know you said they are the numbers that are in the blue and the red, correct?
Yeah.
That's 0, and you got what's the other number?
So that's 0, 0, 1 and 1, 1, 1. So that's, oh, not 1, 1, 1. That should be, did I draw 1, 1, 1 on here twice? That should have been a 1, 1, 0.
I thought that was a 0. That's all.
Oh, man. Okay, so hold on a sec. But you guys get the idea, right?
Yeah. Mm-hmm.
Yeah, that should have been a 0. That, yeah, because that's 1 and 0. That's still 1. So, yeah, okay. So that's a 0, not a 1. Actually, hold on. That's still incorrect. That's a 1. This was a 0. Yeah, and then, so this is 1, 0, 1. So then we would check by substituting. So if we substitute this into the first one, we have 0. Okay, so this one I wrote down wrong. Zero, 1, 0 is the solution. 0, 1, 0 is that solution. So plugging in a 0 for the 1, for x1, that's 0. Don't care for x2 because it's not here. And then a 0, 0 plus 0 is 0, so that's good. And you would do that by doing like left side of 1 with x1 replaced with 0, x2 replaced with 1, x3 replaced with 0 equals, etc. Don't do the thing where you assume that assume that the thing is true and then go from there. You would like show that these are solutions using left side, right side proofs. And does it also work in the second one? We have 1 plus 0. Yeah, that's 1. And then we have in the top one, we have 1 plus 1 is 0 because we have 1 and a 1, the zeros that don't care. And then here we don't care about the first one. So 0 plus 1, that's 1. Yeah, so both of these satisfy our system of equations.
So Peter, I have a question. When we do this for 3B, because we're doing row reduction then, and then we're just doing vector parametric form and all that, would we only have, since we only have two perimeters, or not perimeters, I can't talk right now, but you know what I'm talking about. Is that the same as P1 and P2?
Well, so you just say P1 and P2 are members of Z2. They could be either a 0 or a 1.
Right, but do you know how sometimes in some of them you have like a P1, a P2, P3, because for the different things you're representing? And this one I only have P1 and P2. Is that at all because this is in Z2 or no?
No, it has more to do with the number of unknowns and the number of equations.
Oh, okay. Okay.
How many equations do you have?
2.
And how many unknowns are there?
What do you mean unknowns?
Sorry, how many independent equations did you have? So that comes down to
2.
The dimensions, and then we have 2 independent equations. So that means we expect the number of parameters to be equal to 4 minus 2, which is 2.
Right, okay.
Yeah, it doesn't have anything to do with the fact that we're in Z2.
Okay.
Okay.
But sometimes when we write, at least for the other test, because I don't fully understand the whole vector parametric form thing, I would always end up with like P1, P2, P3. You can have times where it's just P or just P1 and P2, right?
Yeah, and sometimes you just don't end up with any parameters.
Okay. Okay. That makes sense.
Yeah. Yeah. Okay, so are there any more questions about 3A? Okay, well, hearing none, are there any questions about 3B?
If we gave you, I don't know if anybody else wants to do this, so we don't have to if you guys don't. If we went off the first 2 equations you had, like x1 plus x2 equals, and could you show us how to write that up in vector parametric form?
Yeah, sure. I can do that. We'll just use the system of equations from my example here. I just learned how to use this lasso tool, so that's kind of fun, except for when it doesn't work. No, that's not going to grab. This is really hard. I feel really bad for professors that have to do this every day. Okay, so we've got this as our set of equations. So that means I'm just going to, so from this it follows, and I'm just going to start over here, that we would have, actually, so from this it follows, we've got 1 x1 plus 0 x2 plus 1 x3 equals 0. And here we've got 0 x1 plus 1 x2 plus 1 x3. Whoops. Come on. Equals 1. So from this it follows. Now I'm going to move up here. that our augmented matrix is equal to 1, 0, 1. And I guess I did still skip a step, but you'll have to forgive me. And 0, 1. So, oh, this is already in Hermite form, right?
Yeah.
Cool. So I didn't actually have to do any row reduction. Go me. So from this, it would follow, and we just get our original equations back. We have x1 plus x3 equals 0, and x2 plus x3 equals 1. So if I want to move x3 over to this side, like you usually with base 10, we have the ability to add a negative number to cancel it out. With this one, since we've got a coefficient of 1 here, we just add x3 to this side, and that'll move it to the other side. So this becomes x1 equals 0 plus x3. And same thing over here. If we add x3 to both sides, we get that x2 is equal to 1 plus x3.
And that's because it's in Z2?
Yeah, it's because it's in Z2. If I want to undo, like if I want to make a 1 a 0, I have to add 1 to it.
Okay.
So if I want to make one, if I want to move something to the other side, I just add it to both sides.
Right, so there won't be any negatives and like no negative
Yeah.
P1s or P2s.
If you have a minus sign in this question, you've done it wrong. Because the only numbers you can have are 0 and 1. So this, from here, we can write that x1 is equal to 0 plus 1 times p1, and x2 is equal to 1 plus 1 times p1, and x3 is equal to 0 plus 1 times p1, which is just p1. And this is where p1 is in, wow, this is really struggling today. Is in Z2. So this would give us, oops, and I forgot a conclusion bar between these two. This would give us x1, x2, x3 equals 0, 1, 0 plus p1 times 1, 1, 1. And that would be my vector parametric form. And again, this is P1 in Z2. And that's my vector parametric form. And to check this, I'm going to come over here. Well, let's let P1 equals 0. That means that x1, x2, x3 is equal to 0, 1, 0 plus 0 times 1, 1, 1, which is 0, 1, 0. And let P1 equal 1. That gives us x1, x2, x3. There we go. I was just holding my pen, the stylus, too much off to the side, which is why I was having writing errors. Anyway, 0, 1, 0 plus 1 times 1, 1, 1, which is equal to, well, 0 plus 1 is 1. 1 plus 1 is 0. And 0 plus 1 is 1.
Wait, but this isn't how he wants us to check it on the test.
How does he want you to check it on the test?
Oh, I'm sorry. I thought you were showing us a different thing just to check our Victor. I thought we were doing it by subbing in.
How does he say?
You know, where it's like,
oh yeah, by row reduction and check. Yeah. So yeah, you would substitute by checking in. Well, so but this is how you actually get the things to substitute in.
Okay.
I'm not checking yet.
Oh, okay.
I'm listing all of the solutions.
Okay.
So that gives us that our solutions, that means that x1, x2, and x3 are in the set containing 0, 1, 0, and 1, 0, 1, which I believe is what we had over here, right? 0, 1, 0, 1, 0, 1. Yeah.
Computer, can you move it down some? Up a little bit so I can get the screenshot. Right.
Yeah. I mean, you'll have access to all of this. I put the link to these OneNote slides in the same post as the video.
Video, yeah, I'm doing it on my paper. That's why. Take this shot. Thank you.
Yep. But yeah, so, and then you would, again, show by substitution that these work. You could even show substitution in the matrix form, maybe.
Mm-hmm.
But yeah,
he doesn't want us to check with the left side, right side thing. I get so nervous that he's going to take off.
So the meaning behind like do everything as I do in class, no changes, no variations, no omissions, just means you have to follow the syntax rules. As long as you're within the syntax rules, you can play the game however you like.
Right, but at this point, I don't think any of us get all of the syntax rules. So yeah. I see what you're saying, though.
Yeah. Because I remember in Calc 1, he was showing us a way to do it, and I found a faster way, and I figured out how to write it in the syntax. So I did it that way, and I got full credit. Just because it was still in the syntax. It's like, think of the syntax like a programming language, although none of you are computer science. Well, you guys should learn programming. Anyway, so yeah, so then you write your answers in here, and then you write it in functional form. I don't quite remember functional form off the top of my head, but that's easily found in the Gabry packet. Okay, so I think that's pretty good. Let me rename this stuff. I'm trying to get into a better habit of like naming the slides. Let me just rename that real quick. This is 3A example. And this is 3B example. Okay. And this is VPF format. Okay, so 1B, we good to move on to 1B?
Before we do that, I had one question on 2B, if everyone doesn't mind. I think a couple of us were struggling with how to write our vector parametric form for 2B2 in the same way he has it on the test.
2B.
And I think Sylvia tried to clarify with him, but then we didn't get anywhere, so.
So like down here?
Yeah.
So let's see, what do we got? Let me just see what this is. So this is solve the following system of equations in complex numbers by row reduction. Okay, so basically we're doing, so again, we're just doing row reduction, but this time we're using the complex number system instead of just the real numbers. So yeah, you'll end up with, well, so what exactly are you confused about with that?
My final vector parametric form does not like fit into what he has.
Like doesn't fit into the space here?
No, like it doesn't even, like I have, like for one of them is, it would be 2 plus I, P or whatever. But for the others, I don't have any I's or you know what I mean, in them. So then like, but he has it written up so that you would for like Z2.
Well, so if you don't have an I, that means you've got 0 times I.
Okay. But then when people, okay.
Or and if you don't have a real part, that means the real part is 0.
Okay, so like if we had for Z3, if it was, we just had maybe P for Z3, then it would be 0 plus 0. And then.
So if you just have P, then that's, let me just write that. This isn't 1B. This is, so if you just had P and you wanted to write it as a complex number, that would be equal to P times 1 plus I times 0, right? You could even take it back farther. This is P is equal to P times 1, which is equal to P times 1 plus 0, which is equal to P times 1 plus I times 0. So if you just end up with a P, then your complex number is 0 plus I, or sorry, 1 plus I times 0.
Right, but on his test, he doesn't have any room that you could do P times. So are we then just saying we would put in 0 plus I times 0 and then plus at the other side P?
Well, so in terms of, are you talking about in terms of just putting it on the answer sheet?
Just like putting there, because I've seen people get minuses before or like -1 because they didn't write it there the way he thought fit.
So you'll end up having some kind of push vector here that doesn't have a parameter on it. That's just some constants.
Yeah.
And that's what goes here. And if your constants, like if you say you don't have any I's in your constants, then this is just zeros. If for whatever reason all your I's disappear.
And if you have one that doesn't have any constants, it would be all zeros too.
Yeah, you would just put a 0 in there. So like if you had like 5I, that's 0 plus 5I.
Okay, and that's why he just has the 1 plus, because I maybe it's going to be different for everyone, but I think there's only going to be 1 P.
Yeah.
That's the way it's solved. I don't think there's a P1, P2, P3.
Yeah, because, okay, so how many equations do we have?
2.
2, and how many unknowns do we have?
3.
What do you mean when you say unknowns? You mean parameters?
No, I don't mean parameters. I mean, like, see, we have Z1, we have Z2, and we have Z3. We have three unknowns.
Yeah.
So you're either going to have, well, so let's see here. So if both of these are independent equations, then you're going to have 3 parameters. Sorry, not parameters. The dimension of your space is 3. And if you have 2 independent equations, then that means you're going to have 1 parameter.
Right. So then basically at the bottom for everybody would just be plus P after we fill it in.
Yeah, it would be plus P times some vector. It's like, it's just like in this. You would end up with P times some vector. You'll have a push vector, because it doesn't have any parameters associated with it, and then P times some vector. So you have your push vector and then space for P times some vector.
Okay, that makes sense. That makes way more sense. Okay. And then for the for every K is a member of 1 through, we would say what, 1 through 3?
It depends on how many parameters you have. So if you only have 1 parameter, just be 1.1, right?
Okay. And then what does he mean at the bottom where it's like PK is a member of?
Well, so then you have to say what what set PK is a member of. Is it a real number? Is it a complex number?
Well, what do you mean? How do you know what set? I don't understand. I'm sorry.
So I think in this case, it's going to be a real number because you can take any complex number and multiply it by a real number, and that just scales it, right?
Right.
So I think this is just going to be a real number.
Okay.
It's
so
like
the fact that it's C to the third or whatever, it has that's just telling us what our dimensions are.
Yeah, that's telling you what your source set and your target sets are. And then, yeah, that doesn't tell you what set your parameters come from. Though, maybe in this case, the parameters are also complex numbers. I don't know off the top of my head.
Okay.
You might be able to see it in Juan's
Yeah,
exam.
he didn't solve this one.
Okay.
Yeah. But that helps things.
Yep. Cool. So yeah, let's take a look at 1B. So let me just get back over here. I'm gonna just delete this. Oh, I can also select things like that. Cool. Okay, so this is one B. Okay, so this one, I remember helping people out with this one in the fall of last year. So let's see, that's 1A. So here you have to find, if possible, a flat F1 that's a subset of R5 of largest possible dimension such that parallel of F1 to F and prove your assertion. So I'm assuming F is your flat from the first question. No. So in this question, what is F?
I don't know. He didn't have a solve for F. I mean, at the beginning, when you plug in what your A, like how you can figure out what your A or B's are. Or...
Yeah. So that would be a question that would need to be answered is, well, what is F? What are we talking about here? What I think he means, and
he does say at the top information as in 1A.
Yeah, so I think F, you should ask him for clarification on this, but I think F is your solution from 1A. He has a tendency to copy paste and not always change things. So I think F is probably flat of S. But somebody needs to ask him.
Dude, he doesn't answer questions. I vote Sylvia.
Okay, well, so what does it mean if two things are parallel?
They have the same push vector.
Not necessarily.
No.
So let's think about it in just in R2. This is just our regular Cartesian coordinate system. You can think of a line as a line is a one flat, and the place that it intersects the y-axis, that's its push vector. I can have two lines that have the same push vector that are not parallel. They intersect at the push vector. So try again. So in R2, so what does it mean when two lines are parallel?
They would have the same slope?
Yeah, they have the same slope. And then the picture looks like that, right?
Yeah.
So what do you notice about these two lines? And don't say they're parallel.
They don't intersect?
Exactly, they don't intersect. So what does that tell us the solution space is for this?
The empty set?
Yeah, it's the empty set. So you have to find some flat F1 that doesn't intersect F in R5, right? I think he's got a definition for parallel somewhere too.
Say it again. You said it would be the empty set?
Yeah, where their intersection, the intersection of F and F1 is the empty set.
Empty solution set, right?
Yeah, the empty set. So the intersection of F1 and F is equal to the empty set.
Okay.
If this is, let's just call this F and this F1 for a sec. Because these each describe a set of coordinates x comma y, but the two sets don't have any members that are the same. They don't intersect. And at least in R2, that's kind of our intuitive definition for parallel. Has anybody found in the notes package whether or not he's got parallel in there at all?
I have not seen anything about parallel.
Yeah, I mean, there are a couple things, but it's like, it shows that, if once you solve a system and, they don't equal each other in the end, then it shows that they're parallel or something like that. But yeah.
Yeah, see, so here on page 40, he's talking about parallel lines. Since they're parallel intersect, they intersect is the empty set, and they don't intersect, yeah. Any more? Yeah, and then it just goes back up to my first instance of parallel. So yeah, two flats are parallel if they don't intersect. So your task here is to find some flat that doesn't some one dimensional that has one parameter that doesn't intersect the flat that I think you found in 1A.
So the flat from 1A has a dimension of 5. So he's asking the dimension of F1, the one that runs parallel, and it's not going to have the same dimension?
Well, so they both sit in 5 space, but how many, let's see here. So this has 5 unknowns. It's the dimension of the space we're in is 5. And the set of independent equations here was 2, right? Because this was not an independent equation because it was the sum of the first 2. So we have the dimensions of our vector space is 5, and we have 2 independent equations. So that means this is going to have 3 parameters, which makes it a 3 flat, right? So the flat that you find in 1A is a 3-dimensional object sitting in a 5-dimensional space. And for 1B, you're asked to find a 1-dimensional object that sits in 5-dimensional space that does not intersect the 3-dimensional object you found in the first problem.
So wait a second. You're saying that, I'm sorry, could you say it again? The first one was showing a 3-dimensional or a 3 flat.
Yeah.
And in 5 dimensions. So
right.
This one would be showing a 1 dimension but not in 5 dimensions. You're saying?
No, it's still sitting in R5. It's kind of like, so let's extend our intuitive understanding of this a little bit and consider something in R3 for a sec, because we can still draw that one. So so this would be an analogous problem. So let's just take the X, Y, Z coordinate system. Again, Cartesian coordinate system. This is X, Y, and Z. And let's say that we've got, let's say that one flat is just the XY plane, right? And it just goes forever in all directions, but only it sits on the XY plane, okay? And then let's say we have a line that intersects the Z-axis somewhere up here. Let's just call that at point B, at like Z equals B. So this this plane down here, the XY plane, would be a 2-dimensional object in 3-dimensional space. And this line sitting on the z-axis above the xy plane would be parallel to this plane because it doesn't intersect it. This is a two-dimensional object sitting in three-dimensional space, and this is a one-dimensional object sitting in three-dimensional space, and they don't intersect. Does that make sense?
Kinda. So
My
how
drawing's
do you
not
even show something like this or solve for it?
Well, so if they don't intersect, what is true about them? I have to remember how this part works. So like here, these two don't intersect. And if you try to do row reduction with them, you end up with a contradiction, right? Like, let's just take, as an example, let's do y equals x plus 1 and y equals x plus 2. And if we were to recast this, we would have minus x plus y equals 1 and minus x plus y equals 2. Oh, that's not a 2 at all. And if we were to try to do row reduction here, we would have our augmented matrix would be equal to minus 1, oops, minus 1, 1, minus 1, 1, 1, 2. And if we did row 2, come on.
Except here we would actually be subbing in the equations we got from our first flat system from F.
Yeah.
Rather than the X and like how you're showing us with the X and Y. So it's like doing that and then row reduction.
Yeah, so you're going to end up using, I think you're going to end up using row reductions to find a contradiction. So here, if I do R2 replaced with R2 minus R1, the first row stays the same. And if I do minus 1 minus minus 1, that's 0. 1 minus 1 is 0, and 2 minus 1 is 1. So see on this line, I have something that says 0x plus 0y is equal to 1. Well, that doesn't work, right? This basically becomes 0x plus 0y is equal to 1, which is 0 equals 1. That's a contradiction. So there we reach the contradiction. So that we can show that these two lines don't intersect by showing that, hey, we reach a contradiction when we try to do row reduction.
So that would be our proof, just showing the contradiction in row reduction.
Well, so I think we're going to have to kind of work backwards though. Because here I gave you both of these things and you could show a contradiction. Here one of them is unknown. But you know something about F. And I think the important thing to know about F is going to be its push vector. Because if you can come up with some F1 that, how is it? I'm trying to remember. Don't want to lead you guys astray. There's a way to do this with set theory, and I have to remember how to do that. It's been about a year since I've looked at this problem.
Well, how would this be done? Would we be looking in the packet of sets then to figure out how to do this? Or because wouldn't this be in the notes packet somewhere?
Yeah, so if A, oh, come on, what is going on there? I'm not even touching my thing. Why are you doing that? Pardon me while I try to fix technical difficulties. Yeah, what's up? Uh-huh. Oh, that's what's up. I guess it depends on how the other people here feel about it.
I'm cool with it.
Yeah, I'm fine.
Okay.
Yeah, that sounds really good.
Okay, yeah. So after troubleshooting the problem for a sec, I think my stylus is kind of broken. It's it won't unpush. So I guess I'll just be using my mouse to draw things for. It's a Huion. Yeah, I can probably do that with this one. I'm just not going to do it right now. I'll just try drawing with my mouse. Let's see how that goes. So if you have A intersect B, oh, this is really hard, is equal to the empty set. Oh man, that's not going to work at all. One sec. Let me just go grab a paperclip and try to just bust this out.
Did anybody see this in the note packet anywhere?
I think it's one of those things that you have to infer from the sets packet. I'm trying to remember how the definition for intersection for empty sets works. Or, I mean, yeah. Oops. Nope, that is still broken. There we go. You gonna work now? Nope, that is still not being happy. It really sucks. Okay. Okay, so to show that two sets don't intersect, you have to show that they're not subsets of each other. B is not a subset of. Okay, so no, I think it's something in my computer because now it's doing it with my mouse. What? A. Basically, you have to show that the two things aren't subsets of each other.
So in the second one, then we're showing that they're perpendicular. So you would be showing that they are a subset of each other, or that there is somewhere.
So if they're perpendicular, so what's the definition of perpendicular in linear algebra?
I have no idea.
Okay, so if two sets are perpendicular, that means that each of the let's see here, come on. That to show that they're perpendicular, you would show that hey, nope, now it's still not working. Show that the one flat that you find is perpendicular to each of the basis vectors, each of these vectors in the vector parametric form. You show that the flat that the new flat that you find is perpendicular to each of these by showing that the dot product between each is 0. So you would take the flat that you find and take the dot product with this one, show it 0, take the dot product with this one and show it 0. And then that's how you would prove that a flat is perpendicular to another flat.
Say that again. You get to show that the dot products are equal to what again?
0. That was one of the definitions that we used in exam 1A.
So basically, to find it, we'd have to think about it. How would we?
Well,
prove?
yeah. So to find it, you would actually just take all of these vectors in like from your original flat, and it's kind of like question.
That one we solved in the last exam.
Yeah, it's like the one you solved in the last exam.
But we could do it the same way.
Yeah, because then you would find a vector that's perpendicular to the whole flat.
Okay, I get that. Then what does he mean by the skew, the SKW? I still don't understand how to solve the parallel one at all, but I do understand the perpendicular one. What's he mean by the skew?
It's neither parallel nor perpendicular, so that means it intersects at an angle.
This seems like a C problem. Not a B problem.
It's a solid B problem if you've got the definitions for parallel, perpendicular, and skew. And I don't have all the notes packages that he's posted, or I haven't downloaded all the notes packages he's posted. He has sent them to me, but I do not have time to read them. So let's see here under exam 1B. Oh, it just keeps downloading exam 1B. I don't want to download exam 1B.
You have to click the little paper, so it can pop up.
Yeah, but I don't want to look at exam 1B. I want to see if there's material that he wants you to reference for this exam. Like if there's any other notes packages, pages from student exams, tutoring, course materials.
So like for 1B, if we only solved 1B2 and we couldn't figure out the other two, he wouldn't give us any credit because you have to try and solve the whole problem, right?
No, you would get credit for the one you solved. So so the whole problem's worth 6 points. The first part is worth 2 points. The next part is worth 2 points, and the last part is worth 2 points. So if you only solve this part, you would get 2 points. If you want all 6 points, you have to solve each part.
I think he's good with us, like not trying stuff. He just gets angry when we try stuff and fail.
No, he just gets angry when you write nonsense. If you try stuff and you don't know how to do it, and then you submit the answer that is just like spaghetti code or just doesn't make any sense, he gets frustrated with that. Yeah. Mm-hmm. Yeah. So did you take a look at like some of the past exams? Yeah, I don't know. Again,
Did you write it up like some of us dropped our final write-ups in there? Did you write it up similarly? Okay. If you wanted to compare sometime, we could. I got 2 points off for format, but otherwise I got everything. So I think I kind of get the format right now. And I don't mind dropping my final write-up of exam 2 in there too. So maybe we could all follow a similar format. It sucks to get points off for that. Yeah, if you don't do it right, he will take it all off for that. It sucks.
Yeah.
Peter?
Yeah, what's up?
For 1B, I don't know if we had really discussed like how to go about finding that. It seems like, I'm not sure, but it seems like in the finding subflats part of the problem notes, specifically on page 34, 35 of the PDF, but 34 on the thing. It seems like there may be some examples that are kind of like that. I'm not sure. I can't really dissect it yet, but it just seems like
this
seems
is
relevant.
Yeah, I think this is the right spot to be looking. So here, find a one flat where this flat is a subset of this previously described flat. Yeah, so let's see what he's got going on here. So here he wants you to find a flat. So here's another one where he wants you to find a flat G that's not in this flat. What's the GN? What's flat GN? I haven't read the packet, so I don't know what that is. Yeah, he's got a whole finding subflats part here. Cool. So here he's asking you to find a point. Find a point, and then find a 2 flat. And so, yeah, so looking at this example on page 34 of the packet, 35 of the PDF, this is find a flat that's not a subset of this other flat. That's what you have to do for that's similar to what you have to do for for the question on your exam. And actually a simple way to do it would be to take one of the vectors that you end up with in vector parametric form. Take one of these vectors, keep its parameter, ditch everything else, and shift it. So keep one of the vectors, ditch the other vectors, and change the push vector so that it doesn't have anything in common with the original push vector. Because then it'll be going in the same direction and it won't intersect it. Did that make sense?
That's for parallel, right?
That's for parallel, yeah.
Okay.
Yeah, to find a parallel flat, you end up in the 1A, you have something that's got 3 parameters. You pick one of those vectors, ditch the other 2, and pick a different push vector, and that'll give you a parallel.
Okay, because in one of the parts, in another part section of the notes, it says something about like when he talks about flat form, he mentions how like that form is kind of like y equals mx plus b. So yeah, I was wondering if just changing like that portion, keeping that portion and then just like changing everything else, would that make it parallel? Because when things are parallel like that, it's like they have the same slope but different, everything else. So.
Right, yeah. So that would be close, but it wouldn't be a one flat. You know, it would be a however many flat it was.
Oh, okay. Thank you.
Yep. And if it was, so if you had like a 3 flat in R5 and you just tried to move, like just change the push vector, it would still have, it would still intersect in some places.
So the best, so just to clarify what you just said, so the best thing to do would be just to change everything else but keep the push vector.
No, keep one of the basis vectors and change the push vector.
Oh, change the, okay, thank you.
Do you think we have to prove that, and how would you do that?
So you would prove that they're parallel. Well, so you would at least prove that they don't intersect by showing that if you try to take F1 intersect F, you get the empty set. I'm not sure if there's another part to the parallel definition, like about it going in the same direction. Or if just not intersecting is enough. It might be in one of the other packets. I was looking at linear spaces. Let me download this so that I can maybe find in text. Nothing about parallel in that one. Yeah, I would look through, maybe it's in the flats package.
I see nothing in there.
Nope. But yeah, I would look through some of the packets. Maybe it's in problem notes 2, and just start doing searches on parallel to find the definition. And if it's not in any of the packets, then you're like, hey, Dr. Bagchi, this thing that you're having us do, it's not defined in any of the packets. Yeah, I don't see it in the Gabry packet either. Yeah, he didn't teach us that my semester. Nope, I already downloaded linear systems. I've already downloaded linear spaces. But yeah, sorry my stuff is broken. I'll have to try to figure that out between now and next week.
All right, so since you can't really draw anything up, can I ask a question on 3C? Unless people had more questions on 1B?
So 3C.
It actually seems like simpler than 1B. And I don't want to lose all the points for 1B, but I'm not sure if I'm going to be able to figure out how to solve the whole thing. So for 3C, this seemed pretty simple. But I'm sure there's some kind of twist if it's a C problem.
Mm-hmm.
What is the difference between like when he's saying a 0 flat compared to like what we had maybe in 3B, which was, hold on, let me see. we had a 2 flat.
Right.
So,
Well,
uh-huh.
let's say, so what is a 0 flat?
When the dimension is the independent equations is equal to the dimension.
Yeah, but so what kind of object is a 0 flat? Is it a line? Is it a point? Is it a parallelogram? Like, what is it?
I don't know.
It's a point.
Yeah.
So 0 flats are points. So in this first one, you just have to list all of the points in Z2 to the 4. Or in S of Z2 to the 4. S of Z2 to the 4. Yeah, so it's all of the points in your system of system of equations.
So how would you? Okay, so I guess.
Oh.
Mhm.
I'm having trouble parsing this part here.
Yeah, so it's our like the system of equations we got when we solved for it, which was on like I think 3A and then also a little bit on 3B, like how many.
Mm-hmm.
And so we had 2 like independent equations when we did it. But so how? Like what? How, I don't understand. Like what do you mean? Like how would we solve then for a 0 flat? Isn't that just how do you solve for the points?
Well, that's just all the. I mean, that's just all the points. You actually listed them out previously.
So it's the exact same for a 2 flat as it would be in a 0 flat?
Well, so what you were coming up with in 3A and 3B were all of the potential solutions, which are all the points that are in S. The descriptions that we were giving, so like this describes a 2 flat. Or a 1 flat, sorry. This describes a 1 flat. And then all the points in this 1 flat are here.
I'm sorry, are where?
Are here down at the bottom.
Oh, okay. Right, so then, but I don't understand. How is that the same then when he has us write out what the, when we wrote out, it looks like it would be the exact same thing than what we wrote out earlier, right?
Yeah, I think so.
But then how could he have one for a 0 flat, 1 flat, 3, like they must be different. Especially if this one's a 2 flat, there wouldn't be the same number for all of them.
Well, so is it possible that some of them might be empty? Like with our system, it's going to describe a 2 flat, right?
Yeah.
So can we have a 3 flat inside a 2 flat? I don't think we can. There's not enough space. Yeah, I would have to review Juan's exam. Did he do this one?
He only did the first 2.
Oh, okay.
I know, yeah. All right, thanks. I thought it looked easier, but it might be more confusing. I can try reading up on the notes. Thanks.
Yep. Again, this was something he introduced in the course after I took the course.
All right.
Same with the perpendicular skew. Not perpendicular. We did perpendicular, but we didn't do parallel or skew. And 1C is, well, that's a lot of work. I would just skip 1C. We talked about 2A and 2B. What's 2C? That's another by row reduction. Oh, this is in Z7 though. So 2C is kind of like the 3s, like 3A and 3B. But instead of mod 2, you're in mod 7. So your digits go from 0 to 6.
Okay, but basically we're solving the same way.
Yeah, it's the exact same way.
Oh,
and it's
okay, so that might be easy to make up points if I'm not able to figure out 1B.
Yeah, you should be able to get 5 points on that one pretty easy. Just remember in mod 6, again, there's no subtraction. So if you want to if you want to be able to like make something 0, you have to find the thing that you add to it to get 0. So like if I had like 6x and I wanted to kill that, I would need to add 1x to it, because 6x plus 1x is going to be 0x.
Okay, so then if you had like 3x, you'd want to add 4x to it.
Yeah, that would.
And then it would make it back to 0. Okay.
Yeah.
Okay, thanks. Because I
Yep.
want to mess that up.
Yep, it's the same game, but with 0 through 6 instead of just 1 and 2.
But the same thing, you can't subtract it all. You're trying to.
Right. The only things that he gives are is you can add and you can multiply. There's going to be a similar. I think it's mod 7. So if you do the multiplication mod 7, I think that's how multiplication will work in this one.
Okay.
This question asks you to write out the multiplication and addition tables, and I just want to tell everyone that you can Google that and fill that in and get 2 free points. So just do that.
Yeah, there you go.
Which one? I'm sorry. Which was that?
It's for 2C.
Oh.
You get 2 points just right there. That's a good catch. So that's a free 2 points right there.
Wow. Thanks to whoever said that.
Because you only get 1 point for finding vector parametric using only additions. Only addition. Okay. Yeah.
Wouldn't the vector parametric form always be addition anyway, since our equations are in addition? Or solution?
Sorry. This is vector parametric form using only addition. Yeah. So as opposed to like having a minus sign instead of a plus sign.
Okay. Okay. But he's not throwing any curve in there. It's just what we already know.
Yeah, it's just what you already know.
Okay.
So that by addition only, that just means for the parameters themselves. Like you could still hypothetically have negative numbers within the parameters?
No, you can't. So since we're in Z7 doesn't have any negative numbers. It only has 0 through 6.
So when you subtract the like x values from the one side of the equation to the other, you just make those positive?
So there is no subtraction. That's what I was just trying to explain. It's like if you want to like get something to be 0, you have to add the number that makes it 0. So like if you've got a 6 and you want to move it to so if you've got 6x on one side and you want to make it 0, you would add 1x to both sides of the equations, and that would make the 6x go to 0, and you would end up with a
Gotcha.
1x on the other side.
Gotcha. Thank you.
Yep. Yeah, so if you move, like the moving to the other side of the equation doesn't quite work like it does with integers, because we don't have negative numbers. We just have 0 through 6. So if you've got 3x on one side, if you add 4x to both sides, the 3x goes away, and now you've got a 4x on the other side. And that's totally fine. Those two statements are still equal. This is hard without writing. I don't have a whiteboard or anything, so.
All right. Well, I think if no one has any other questions, that's as much as we can probably do tonight, huh?
Probably, yeah.
Well, Pete, I was about to say, for the last like 20 minutes, if everybody wanted to leave, they can. I wanted to ask you because I kind of got a late start because of family issues, actually family deaths in my family. So I'm actually around 2B, but I wanted to go back on my 1A because I think something is wrong. I did something wrong with my row reduction. I'm not sure like which way I can fix it.
Okay. Well, yeah, we can try to figure that out. It's going to be kind of hard to do it over in this medium. It might be better, like if you posted it into the Discord.
Yes.
Ask other people to check stuff out.
I think Alicia, if I'm pronouncing her name right, I know we have like similar numbers, but just in her like her row 2, column 2, she has a 0 where mine is -1. So basically, our numbers is in a different order, but they're the same numbers. If that makes sense.
Yeah, but that's going to give you completely different answers.
Correct. And
Yeah, we
I'm
can
messing
take a
up.
we can take a look and see if there's anything like glaring.
Hey, Shayana. I'm probably saying your name wrong too. They do
Yes.
have awesome, you can Google row reduction calculators, because sometimes at the beginning when I was first figuring out row reduction, I was way overthinking the steps and I couldn't simplify it easy enough. And then I would plug in my numbers in the calculators and it would show the steps and I would be like, oh, and it helped me learn row reduction much faster.
Okay.
So
Thank
if
you.
you
Way to do
Google
it,
like
too.
row reduction calculator, it might it might really help out.
Okay. Thank you.
Yeah. Do those row reduction calculators like show you the steps in the row reduction?
Some of them.
Yeah, they do.
Yeah. So if you can find one like that, it can help you learn row reduction a little better.
Okay.
In higher level courses, you're just going to use MATLAB. So if MATLAB's you have to pay for that program, but there's an open source version called Octave that has most of the functionality. So you guys should check that out, get a head start on MATLAB. As most of you guys are math majors, and as math majors, you're going to be using that a lot, or at least they do at Temple. Or at least we did in my numerical analysis class I took. I took exactly one math class at Temple. I got a C+, and I'm like, nope, I'm good.
Does anyone know who got the 44 on the test? Because whoever it is, congrats to you, man. Somebody.
I don't know who got the 44.
What?
I
I
think we posted in Discord more.
On the test. Whoever got it, congratulations. I don't know.
Yeah, I gotta. That means somebody figured out some of the C problems. I don't know who, but congrats.
Let's see.
Peter, can you show the chart you made for 3A again?
Yeah.
Okie dokie.
Did you just take a picture of your computer screen with your cell phone?
No, it's with my computer.
Oh, okay, good.
I'm gonna try to knock that out, so it's one for later.
Yeah. And actually, so I made the box extend all the way out into you probably wouldn't want to extend it all the way out into the answer column like I did here.
Yeah, it's just the show, right?
Yeah, but again, I don't know exactly how to show the work for this one. Because we didn't have to do this. Usually it's drawing boxes around things and using a ruler to draw all the edges. If Solomaya had to do something like this, then I would say copy her format.